Hi, welcome back everyone. Now, before we dive into today's lesson, let's first talk about something super important. The difference between SQL, SQL, or NoSQL databases. To make this easy to understand, I'm going to use analogies like I've used them before. Ready? Let's go. Okay, so SQL versus NoSQL is like an organized filing cabinet versus a scrapbook. Let's have a look at SQL databases. And in our example, PostgreSQL is an example of a SQL database. Imagine you're running a library, and SQL databases then are like those super organized cabinets in the library. Every book or document has a predefined slot, and you must follow the rules to put something in. For example, the first drawer is for books on sports. And each book must have an ISB number, title, author, publication date, otherwise it doesn't fit. Now, if someone asks for the book with ISB number 1, 2, 3, 4, 5, then you know exactly where to find it because it's all neatly organized. SQL databases are structured, which means the data must follow a specific format, like rows in a spreadsheet. And then we have a NoSQL database, and soon we will look at MongoDB. Now, imagine instead of filing cabinets in the library, you have a big scrapbook. You can paste anything you want, pictures, handwritten notes, or even receipts. There's no strict format. If you want to add a page about sports, you just write it however you like and you put it in there. One page might have a picture of a football player with a name and age, and another page might just say, I love running. So, NoSQL databases are flexible instead of structured, and great for when you want to store diverse or unpredictable data. So before you start a project, you need to know if your data is super organized, and you need to stick to a strict format. Then you will go with SQL or SQL. However, if you need more flexibility and you don't know exactly what your data will look like, then NoSQL is your friend. Now, let's dive into Visual Studio Code and let's get coding. I've opened up Visual Studio Code and I've opened it up in a folder that I have on my desktop called week 14-2. Let's create a Docker Composer file. So touch docker compose.yml, and in here I want to configure MongoDB and Mongo Express. So I'm going to start with services, and MongoDB is going to be one, and in there I want to get Mongo as an image, and this will use the latest of the official MongoDB Docker image from the docker.hub, so I don't actually have to write latest, I can leave that away. Then I'm going to give this container a name, and I'm going to call this MongoDB. And this sets a name for the MongoDB container, so we can easily defer to it. For example, when we're debugging. Then I have ports, and this is going to be 27017, and I'll type it again, 27017. And this 27017 maps the container to port 27017, which is used by MongoDB. Then we also want some volumes, and we're going to say Mongo underscore data db. This mounts a volume named Mongo underscore data to the data db folder in the container. MongoDB stores its data files in then data/db. And the volumes ensure data persists even if the container is stopped or removed. Then we also have Mongo Express, and we want to install the image Mongo Express, and again we don't have to say latest. We give it the container a name, and we're going to call it Mongo Express. Then we have ports, and this is going to be 80, 81, and then we have an environment, me config MongoDB underscore server MongoDB. I'll go over that in a second. And then we also have volumes Mongo underscore data. Okay. So from top to bottom, the image Mongo uses the latest version of Mongo Express Docker image, which is a lightweight web interface for MongoDB. Then we have the container name, which names the container. And then we have ports, and this maps port 8081, for example, which is used for Mongo Express to the host machine's port. And this then allows us to access Mongo Express in our browser at port 8080. So localhost 8080, or sorry, 8081, not 8080. And then we have the environment here, and this configures Mongo Express to connect to the MongoDB container, as you can see here. Yeah. And the value of MongoDB, as you can see, matches the container name that we define here. So that's important that these are the same. So we have MongoDB, which is going to be our database. We have Mongo Express that helps us to find data in the database. And we have Docker Compose, which is basically our setup plan. Okay, so let's run this by typing in Docker Compose up /d, and then it's running. And once it's done, we can go to localhost 8081. Then we do that, and it should look like this when you're logged in. And by default, you already see 3 databases, and that is admin, config, and local. And the admin database has the administrator information, so it holds user authentication, roles, and other security related data. And then have the config. The config stores the sharded clusters. So sharding is like a way where MongoDB distributes data across multiple machines. We won't use this at all, for now at least. And then we have the local database, and this is used for replication and stores data, which is specific to our local MongoDB instance. For now, we will not touch these, and we will move on. And we dive into Visual Studio Code again. And in here, we're going to initialize our project. So let's do that. npm init-y. And we are going to install Express, and we're going to install Mongoose. npm install Express and Mongoose. Where Express is the tool for building web service in Node.js. It helps us to handle requests, like if someone visits our website, and send back correct responses. And Mongoose, what we've just installed, makes it easier to work with MongoDB database in Node.js. Remember, MongoDB is a type of database that stores data in a flexible way, as we've discussed before. So Mongoose will help us read, update, and delete data in that database without needing to write all the complex code by ourselves. So in short, Mongoose will help our Node.js app to talk to our MongoDB database, and Express helps us to handle these web requests. Now let's create the index.js file. So I'm going to say touch index.js. In here, we're going to say, actually here, I'm going to say type and module. In index.js, we're going to say import Express from Express, and we're also going to say import Mongoose from Mongoose. Then we're going to say const app equals Express, and we're going to say app.use, and we say express.json. Now, what we want to do now is we want to make a connection to our database and give the database a name. So I'm going to say mongoose.connect MongoDB localhost 27017, my first database, comma, use new URL parser true, and use topology true. So what we do is we establish a connection between our API, between our app and the MongoDB database. Then the localhost, this is the database that's running on our local machine, 27017. That's our default port that MongoDB uses. And then we have my first database, and this is the name of the database that we're going to connect to. And this will be created automatically if it doesn't exist. Then we have these two options here. This Object-C, the use new parser, the use new URL parser here. This ensures the connection string is parsed correctly. And the use unified topology, it improves the connection handling. Okay, let's move on. Now, after we've made the connection, we're going to define a schema and a model. So I'm going to say const item schema equals new mongoose dot schema, and what we'll do here is we're going to give this schema a name, which is a string, and we want a quantity, and this is going to be a number. Okay, so in here, the schema which defines the structure of our data, we have a name here. So this object here, we have a name, and this is a string which holds the name of an item, for example apple or banana or pear, and then the quantity which holds the number of the quantity, for example 5 apples or 5 pears or 5 bananas. Okay, and then we type in const item equals mongoose dot model item, comma, item schema. Okay, so this is our model here, and we used a model as a way to interact with our data, and we have an item here, a variable called item, and this represents the item collection in our MongoDB, and you can think of this as a blueprint for creating, reading, updating and deleting items in the database. So this is what we have used before. For express, const app equals express, app.use express.json, so we can work with a JSON. And then we make a connection to the database, we set up a schema, and we set up a model. Now let's define some routes, and then we'll go to test them as well. So let's do a fetch all items. So we do app.get, and this is going to be similar to what we've done before. So I'm going to say items, comma, and this is going to be asynchronous. So I'm going to say async request response because it might take a while, and then we say const items equals await item dot find response dot json items. So let me explain this as well. So app.get items here, this sets up the route for the path items, and when we visit this route, the server runs the callback function here, this one. Okay, then we have in the callback function we have the item.find. This retrieves all items from the database. It's like if you're in a library, you can ask the librarian to show you all the books in the library. And the response.json items, this sends the list of items as a JSON response to us, or to the user that's asking for it. Let's also set an app.post, and remember it's going to be the same here. We can still do items, we can still do the callback function there, request response, and in here now we can say const new item equals new item from the requested body, and this is asynchronous, and then await new item dot save, and then response JSON new item. Okay, let me explain this to you. So the app.post /forward item here, items, this sets up the route to handle post requests to items. users can send data to this route to add new items. That's the purpose of this one here. Then we have the request.body, and the data that the user sends in the request, for example, in here, name, banana, quantity 10, there will be the request.body. And then the new item.save saves the new item to the database. And then the response.json new item here sends the newly added item as a JSON response to confirm to us that it was saved. Now, why is this asynchronous? And that is mainly because here it waits for the items to be saved, so that might take a little while. Okay, and once the item is successfully saved to the database, the code continues to this line. And just to emphasize again that this part here is, let's see, from there all the way to there, this is our callback function. Yeah, you can see it's a function here, brackets, arrows, and arrow function. Yeah. Okay, and now let's start the server. So we say app.listen. Let's call it port 3000. And we say console.log server is running at HTTP localhost 3000. So let's start this file, node index.js. And what am I missing here? And actually I don't need all this anymore nowadays. So I also, there's a typo there. So there we go. So let's try this again. And now it's running nicely. So remember, I don't need all the options in there. Great. So let's open up the browser. And here we go. What you can see is we're in localhost 3000/items, and you can see that my array is empty. So let's fill it up, and let's use Insomnia for that. So let's create a new collection, and I'm going to call this Express MongoDB app. A new request, and we're going to say in here HTTP localhost 3000/items, and we'll call this, rename this, fetch all items, and then I want another one, another there, and I want this to be a post to the same localhost 3000/items, and then we go to the body JSON, and we might say name. Remember, we need to use this here, name and quantity. So name banana and quantity, we can say 10, it's a number. So let's post this. You can see it's confirmed, and we get the ID here. And now if we say get, you see that we also get this from MongoDB. Wonderful. Now let's also do a put and a delete request. So we can say app.put, and we can do items, and remember we pick it by the ID, we have the callback function, and we say async request response, and in here we're going to say const, and we've done this all before, id equals request.params, and we will say const updated data equals request.body, and then we're going to say const updated item equals await item dot find item dot find find by ID and update, this one, and then we want the ID, and then we want the updated data. I'll go over this in a second, and we will say new true, and let me just save this. Then we say if you have no updated item, then we return response.status of 404 not found, JSON, and an object which is error item not found, there. And then we respond with the JSON updated item there. Let's explain this one. So we first look at this part here. We look at the ID, and so this sets up the route that listens for the put request at the items and then the ID. The ID part is a placeholder for the ID of the item that we want to update. For example, if we want to update an item with ID 12, then the URL would be items/12. Okay. Then the request.params grabs the ID from the URL. So if this would be 12, then this would be 12. And the request.body here contains the new data that we want to update. So maybe we want to update it both the name and the quantity. Okay, so maybe we want to say bananas 9. Okay, and in here then the next part here, the item.find by ID and update. This is a Mongoose method. It finds the item by its ID and updates it with the updated data. And the option here, new, is true, tells Mongoose to return the updated item instead of the old one. Then the next step here is to check if the item with the given ID exists. Otherwise it gives a 404 not found with the message of item not found. And then it's sending the updated item. So if the update is successful, it sends back the updated item as a response. Now let's try this put request in Insomnia. Here. So I'm going to say new, and put. I'm going to rename this one, and this is going to also be renamed. So I'm going to say post item. So this put one here goes to HTTP localhost 3000, and let's now we would have to update the ID, but I don't know that because it's a difficult one, so I'm just going to check this, send, and I'm going to pick up on this ID here. And let me see, do I have everything? Yeah. So I'm going to copy. Okay. So put here, and you can see here that we have a name and quantity. So banana, and let's make it 9, okay? Banana with a capital letter, and I'm going to make it 9. It's 10 now. So there, body is JSON. So we can say name banana and quantity is 9. And of course banana is a string. There. And let's send this. There, cannot put. And why is that? And did I write item instead of items? Let's see. Oh, I did not even do items. So let me write it down. Items. There. Send. Still not. What mistake do I have? And I see a mistake here. This is updated item if right here, this one here. We want to check the updated item. Let's save it. Let's try it again. Send. Still not. Okay. What else? Okay. What I had to do is I had to restart the server, and it worked. Great. So now all we have to do is we have the get, post, put, and now we'll have to do the delete. So let's do that one as well. So we go down, we'll say app.delete, items, // by ID, callback function, async, requests, response, and what do we do here is we say const, and we do the same, ID equals request dot params, just like here. And what we're going to do is we say const deleted item equals, and now we have to await again, and we say item dot, and we will say find by ID and delete. So find by ID and delete. There we go. And we take in the ID as we did before. And we can say if, and then we take the deleted item. If no deleted item found, then we return a response.status of 404.json, and we can say error item not found, just like we did here. Okay, and otherwise we can return the JSON with the message of item deleted And with that we can pass the item, and it is the deleted item there. Okay, so let's try this one out as well. So let's have a look. Let's restart the server for a second there, so we don't have that same problem as we did before. Let's fetch this one here, send. Oh, sorry, I don't need this behind, of course. Get. So I want, this is the only item I have, so I want to delete this one. I'm going to copy the ID. Let's create a new request, and it's going to be a delete, and I'm going to say rename delete item HTTP localhost 3000 /forward items, and we're going to pass in the item, and then we say send item deleted, and it's confirming this item. So now when I try to get all the items, it is empty. All right, now one very last thing I want to do is some error handling. So let's have a look at that. So let's have a look first at the mongoose.connect. What we can do here is we can say .then. So if we are successful, then we can do this. We can say, we can console log, and we can say connected to MongoDB, and otherwise we catch the error, and we can do so we catch the error, and what we can say here is we can console.error, and then we can send a message, could not connect to MongoDB, and we pass in the error. So that's for Mongoose. And we can also, for each of these routes here, these 4 routes that I have, I can put in a try catch block. So try catch, and what I can do in here is I can take in these there, and if there is an error, then I can respond with the status of 500.json, and I can pass in an object here saying error failed to get items there, and I can do the same for the other ones here. So try catch, I can put in this here, and otherwise I can copy in that, and here I can say post items, and I can do the same for the puts, try catch, and I press tab when I do that. Okay, so let's see, all this, and there. In there, and with the catch I copy in this there, fail to update items, and one last one here, try catch, and I copy in this. From where to where was it? There. There. And I copy in this. In there. And then I say delete items. So, it became quite a file and became quite a lesson. I hope this has helped you. It's only a basic schema here with only a name and a quantity. And we will look a little bit more at this in the next lesson. So thank you for watching, and I'll see you in the next lesson.